Good day, class. Our discussion for this afternoon would be all about solving logarithmic equations and inequalities. But before we proceed to that discussion, let us first study some of the concepts that is necessary in order for you to solve logarithmic equations and inequalities. First, we will have how to rewrite logarithms to exponential forms. Second, we will also study what are the basic properties of your logarithms. And the last concept is all about the laws of logarithms. Now let us proceed to our first concept, how to rewrite logarithms to its exponential forms. So in order for you to rewrite logarithms to exponential, you must first learn this notation. Logarithmic form can be expressed in the notation the logarithm of a with base b equals c. Exponential form is being expressed in the notation b raised to c equals a. As you can see, class, the variables that we use for our expressions are similar. We have used the variables a, b, and c. What have you observed, class, with the variables being used in our logarithmic expression and exponential expression? Yes, the variables that we have used in the logarithmic forms are the variables that can be found in the exponential form. Please take note that in our logarithm, our base represented by the variable b is also the base for our exponential form. While the c in our logarithmic form, which is the answer for the logarithm, is actually the exponent of our exponential form. And the variable a in the logarithmic form is the answer to our logarithm. So in order for you to rewrite a logarithm to exponential form, you must understand that the variable in your logarithmic forms are the variables that can be written in exponential forms but in a different position. One thing that you also have to remember before you rewrite a logarithm to exponential form is the restriction that your variable a and variable b must be a positive numbers, and your variable b must not be equal to 1. What is the use of this restriction? Let us go to an example. If you have a value to your a that is negative, take for example the logarithm of negative 8 with base 2 equals to c. When you convert this one into an exponential form, this becomes 2 raised to the power of c equals negative 8. Can you think of a number that we can replace to your c so that our answer would be negative 8? That's correct. We do not have an exponent that can answer to a negative value. So that is the reason why the variable a should be positive number. Now let's go to our b. Why should our b a positive number but not equal to 1? Take for example the logarithm of 2 with base 1 equals c. Take note that your b here is equal to 1. If we convert this one into exponential, this becomes 1 raised to the power of c equals 2. Think again of a number that we can replace to your variable c so that when we raise our 1 to c, the answer would be equal to 2. Again, we cannot think of any number to be replaced to our c so that our answer is equal to 2. Therefore, it should be that a and b must be positive numbers and b must not be equal to 1. Before we proceed to our examples, let us have first a review of how we are going to rewrite logarithms to exponential form. Take note that in our logarithm, the variable b, or the base of your logarithm, will become the base of your exponential. The variable a in your logarithm will become the answer to your exponential. And the answer to your logarithm, which is the variable c, would become the exponent to your exponential. Let's proceed to the example. Logarithm of 32 with base 2 equals 5. Converting class, this will become our base is 2, our a is 32, and our c is 5. So in exponential form, this will become 2 raised to 5 equals 32. Another example, logarithm of 16 with base 1/2 equals -4. Rewriting, this will become your b is 1/2, your c is -4, this will become the exponent, so that is raised to -4, and your a is 16, so your exponential would be equals 16. So you have 1/2 raised to -4 equals 16. Next example, you have the logarithm of 1 over the square root of 5 with base 5 equals -1/2. So rewriting to exponential, our base is 5, so you have 5. Our c is -1/2, so that's 5 raised to -1/2 equals 1 over square root of 5. Again, take note, the values that you have in your logarithm are actually the same values that you will have in your exponential, but in different position. So that is all about how you are going to write logarithm to its exponential form. Keep posted for the upcoming videos on the continuation of our discussion on solving logarithmic equations and inequalities. Do not forget to like and to subscribe to my channel to be updated for the coming videos. Bye!